The driest start to a year in 131 years of NOAA climate records just happened. From January through March of 2026, the contiguous United States received less than 70% of average precipitation, breaking a record that had stood since 1910. The Palmer Drought Severity Index just posted its worst March and April values since the Dust Bowl. 60% of the lower 48 is in drought. And the climate event most forecasters expected to drive the worst impacts of this year has not even arrived. Here is what's happening and what comes next. The driest start to a year in the entire continuous climate record of the contiguous United States just happened. According to the National Oceanic and Atmospheric Administration's National Centers for Environmental Information, the first 3 months of 2026 produced the lowest combined precipitation total for January through March in 131 years of continuous instrumental records. The previous holder of that record was 1910. That record has now fallen. The total precipitation across the contiguous lower 48 from January through March of 2026 came in below 70% of the long-term average. That is not a regional anomaly. That is the entire country. And the dataset that measures it goes back to 1895, the year that the modern continuous statewide climate record for the United States begins. So when you hear since 1895, what that actually means is since records began. There is no continuous instrumental dataset for the United States that goes any further back than that. This is the headline. But it is not the entire story. Because what the National Centers for Environmental Information confirmed in the March and April monthly reports is that this is not a single metric event. 3 separate measurements of the spring 2026 drought each set their own historic mark. And the May 5th release of the United States Drought Monitor confirms that the conditions have not eased, they have spread. The Southeast just recorded its driest April in 40 years. 6 Atlantic coastal states, from Georgia north through South Carolina, North Carolina, Virginia, Maryland, and Delaware, ranked among their 10 driest Aprils on record. Florida hit 98.99% in drought coverage in April. That is the highest single-state coverage in the entire history of the United States Drought Monitor, which dates back to the year 2000. And the western United States, Arizona, Colorado, Idaho, Nevada, New Mexico, Oregon, Utah, and Wyoming, set new April 1st snowpack record lows, all 8 of them, simultaneously. I'm going to walk you through what broke, why it broke this fast, and what comes next. Because the part that has not made the headlines yet is this: the climate event that most forecasters expected to drive the worst impacts of 2026, the developing Super El Niño projected for late this year, has not even arrived. You need to understand the 3 measurements separately. They are not the same thing, and the news coverage has not been clean on this. So here it is. The first measurement is precipitation itself. How much water actually fell from the sky? NOAA's National Centers for Environmental Information tracks this in a dataset called NCLIMDIV, which is the continuous statewide climate record for the contiguous United States. NCLIMDIV begins in 1895. The January through March 2026 total just came in as the lowest in that record, below 70% of average, breaking the prior record set in 1910. The second measurement is the Palmer Drought Severity Index, usually abbreviated as PDSI. This is the operational standard for measuring drought intensity. It combines precipitation, temperature, and soil moisture into a single number, with negative values indicating drought. March 2026 produced a national PDSI value of negative 7.85. April came in at negative 7.56. Both numbers are the worst values ever recorded for those individual calendar months in the entire 131-year instrumental record. The only months in U.S. climate history that have ever produced lower PDSI values are July and August of 1934, during the absolute worst single year of the Dust Bowl. Those months hit negative 8.09 and negative 8.42, respectively. So when you hear that the current drought is approaching Dust Bowl conditions, that is not media exaggeration. By the Palmer Drought Severity Index, the only months in the last 131 years that were worse than March and April of 2026 were the 2 months at the dead center of the Dust Bowl itself. The third measurement is the United States Drought Monitor, which is produced jointly by the National Drought Mitigation Center, the U.S. Department of Agriculture, and NOAA. The Drought Monitor measures aerial coverage, what percentage of the country is in drought, and at what intensity. In late April of 2026, 43.8% of the contiguous United States was in severe to exceptional drought. That is the D2 through D4 range on the Drought Monitor's 5-level scale. That is the largest extent the country has seen since August of 2012. more than 13 years ago. The May 5th Drought Monitor update, released last week, confirmed that the broader picture has not eased. 60.92% of the lower 48 is currently in drought. That is 6 out of every 10 acres of land across the contiguous United States. Any single one of these 3 records on its own would be a major news story. The fact that all 3 are happening at the same time, that is what makes this a regime shift rather than a one-off bad year. Let me give you the Florida picture, because it is the most dramatic single-state story in the current drought. At the April peak, the United States Drought Monitor showed 98.99% of Florida, effectively the entire state, in drought. That is the highest single-state coverage in the entire United States Drought Monitor record, which begins in the year 2000. The Drought Monitor has been tracking U.S. drought continuously for 26 years. Florida just set the all-time record. By the May 5th update, that figure had eased somewhat. Florida is currently at 78% in drought, with another 1% abnormally dry, but more than half the state, over 50%, remains in extreme drought, which is the D3 category. And approximately 22% of Florida is in exceptional drought, the D4 category, which is the most severe level the Drought Monitor uses. This is Florida's most intense drought in 15 years. The broader southeast picture is similar. The southeast climate region as a whole is at roughly 99% in drought, with about 61.5% in extreme or exceptional drought. 6 Atlantic coastal states, Georgia, South Carolina, North Carolina, Virginia, Maryland, and Delaware, all ranked among their 10 driest Aprils on record. And the southeast climate region collectively just had its driest April in 40 years. What makes the Florida number stand out is the historical baseline. Florida is one of the wettest states in the country. It sits in a subtropical climate that historically receives massive convective rainfall during the warm season, along with frequent tropical system rainfall during the summer and early fall. For nearly the entire state to dry out simultaneously, and to do so before the wet season even begins, is unprecedented in the satellite-era drought record. This is not a slow-developing drought. This is a regional climate state that has shifted into a configuration the Drought Monitor has not seen in 2.5 decades of continuous monitoring. Now turn west. Because if the southeast is the story of vanishing rainfall, the west is the story of vanishing snow. On April 1st of 2026, 8 western states simultaneously set new record-low snow water equivalent values. Arizona, Colorado, Idaho, Nevada, New Mexico, Oregon, Utah, Wyoming. All 8, at the same calendar moment, broke their previous April 1st snowpack record lows since SNOWTEL monitoring began in the 1980s. Oregon is the most striking individual case. The state's statewide snow water equivalent on April 1st was 2.1 inches. That is 12% of the median peak. That is the lowest April 1st SWE value Oregon has on record since SNOWTEL monitoring began in 1981. California, which has had a relatively wet year compared to the rest of the West, still ranked as the second lowest April 1st snow water equivalent on record. Across the entire Western SNOWTEL network, nearly 3/4 of monitoring stations lost their entire snowpack more than a month earlier than the 1981 to 2010 reference period. 3 out of every 4 Western snow stations are already snow-free. In May, weeks before they typically would be, the Colorado River Basin, which provides water to 40 million people across 7 states and northern Mexico, recorded its warmest March on record. 13.7 degrees Fahrenheit above normal. That is not a slight warm anomaly. That is March temperatures pushing into territory that historically belongs to early summer, and the reservoir picture that depends on this snowpack is now in operational trouble. Lake Mead, the largest reservoir in the United States by volume, currently sits at roughly 1,055 feet of elevation, about 30% full. The Bureau of Reclamation projects that without significant late spring runoff, Mead could drop into the upper 1,030-foot range by mid-2027. Lake Powell is worse. Powell sits at approximately 3,526 feet of elevation. That is roughly 23% full, more than 170 feet below full pool. And the Bureau of Reclamation's most recent 24-month study projects that under dry conditions, Lake Powell could approach the 3,490-foot mark by late 2026 or early 2027. That elevation matters. 3,490 feet is the minimum power pool for Glen Canyon Dam. It is the elevation below which the dam cannot physically generate hydroelectric power. If Lake Powell drops below that line, Glen Canyon Dam stops producing electricity for the grid. That is a date on the calendar right now. Late this year or early next year, under dry conditions, which the current drought trajectory is producing. The The wildfire data follows the drought data exactly. By May 1st of 2026, the United States had recorded more than 24,000 wildfires nationwide. 1.8 million acres had already burned. That is 50% above the long-term normal and roughly twice the 10-year average for the same period. The National Interagency Fire Center describes this as the worst start to a U.S. fire season in 10 years. The acceleration was visible in March. By March 31st, the country had already burned 1,615,000 acres, 231% of the previous 10-year average for that point in the calendar. The national preparedness level reached PL2 on March 20th, weeks earlier than typical. PL2 is the level at which multiple geographic areas are committing significant resources to fire suppression simultaneously. The May 2026 outlook from the National Interagency Fire Center forecasts above normal significant fire potential across multiple regions through the summer. The southeast Atlantic coast and Florida, the southwest into far west Texas and southern Utah, the Sacramento Valley and the East Bay region of California. These are not isolated regional warnings. This is a coast-to-coast above normal fire risk pattern. What it tells you is that the operational fire calendar, the months when wildfire activity historically peaks, has been compressed. Fire season is starting weeks ahead of where it typically does. That gives the country more weeks of active fire risk before relief arrives, and it stretches firefighting resources thinner across a longer window. So how did 3 separate 131-year records get set in the same spring? Here is the science. The atmospheric driver is something climate researchers call a pattern lock. Right now, a persistent westward extension of the Bermuda High, a subtropical area of high pressure anchored over the western Atlantic, has paired with a stationary high-amplitude ridge in the Rossby wave train over the southeast and the mid-Atlantic. That configuration does 2 things. It shunts Gulf of Mexico moisture transport away from the southeast, depriving the region of its primary moisture source. And it locks atmospheric subsidence over Florida, meaning the air over Florida is sinking, warming and drying rather than rising, cooling, and producing rain. A study published in 2021 in the journal Water Resources Research, led by Hahn and colleagues, directly linked low-phase speed Rossby wave packets to severe contiguous U.S. droughts. The slower these atmospheric ridges move, the more severe the drought they produce. The ridge that has been over the southeast for the better part of 3 months has barely moved. That is the pattern lock. But that explains why the drought is geographically concentrated. It does not explain why it is so deep. For that, you need the temperature mechanism. Climate scientists have a term for drought that intensifies in weeks to months rather than over years. They call it flash drought. The concept was formalized in a 2018 paper by Otkin and colleagues in the Bulletin of the American Meteorological Society. The follow-up paper by Pendergrass and colleagues in 2020 in Nature Climate Change documented that flash droughts unfold exactly on the sub-seasonal to seasonal timescale where current weather and climate prediction is weakest. They are too slow for traditional weather forecasting and too fast for traditional seasonal forecasting. A 2021 paper from Christian and colleagues in Nature Communications identified the central United States as one of the global hotspots for flash drought activity. And a 2023 paper from Yuan and colleagues in Science documented the global transition to flash droughts under climate change. Here's what links all of this back to the spring 2026 record. The mechanism is temperature. Air temperature controls atmospheric vapor pressure deficit through the Clausius-Clapeyron relation. As temperatures rise, saturation vapor pressure rises exponentially, about 7% for every degree Celsius. Higher vapor pressure deficit pulls more water out of soils and out of vegetation, regardless of how much precipitation falls. The first quarter of 2026 was the 4th warmest start to any year in the global temperature record, despite weak La Niña conditions that historically should have suppressed global mean temperature. The UK Met Office projects 2026 as the 4th consecutive year above 1.4 degrees Celsius versus pre-industrial. The result is straightforward. The same precipitation deficit that 50 years ago would have produced a moderate drought now produces a 131-year record. The temperature has shifted underneath the precipitation pattern, and every dry spell that arrives now does more damage than the same dry spell would have done in the 20th century. The longer-term context comes from a 2022 paper by Williams and colleagues in Nature Climate Change. Using a tree-ring paleoclimate network that extends back to the year 800 of the Common Era, they reconstructed soil moisture across southwestern North America and found that the period from 2000 to 2021 was the driest 22-year stretch in at least 1,200 years. About 42% of the multi-year soil moisture deficit is attributable to anthropogenic climate forcing. The 2025 University of Colorado Boulder follow-up extended that analysis and concluded that human emissions are driving the Western megadrought more intensely and more directly than previously understood, including direct effects on precipitation, not just temperature. This is why a precipitation deficit that 50 years ago would have produced a moderate drought just produced the worst drought in 131 years of NOAA records. The atmosphere has changed shape underneath the same weather patterns, and the consequences are showing up faster than the forecasting systems were designed to detect. Here is what happens to the country while this drought continues. Start with cattle. As of January 1st of 2026, the U.S. cattle herd stood at 86.2 million head. That is the lowest the U.S. cattle inventory has been in 74 years. Beef cows specifically are at 27.6 million head, down 1% year over year, and approximately 60% of the entire U.S. cattle inventory is in drought-affected counties right now. The U.S. Department of Agriculture is projecting record beef cattle prices in 2026. And USDA notes, directly, that no meaningful herd expansion is possible until at least 2028. Next, wheat. The USDA's National Agricultural Statistics Service reports, as of May 4th of 2026, that 31% of U.S. winter wheat is rated good to excellent. That is, down 13 percentage points from 48% at the same week of 2025. Kansas, the country's largest hard red winter wheat producing state, has 78% of its wheat rated very poor, or fair. The economist's model from Kansas State University projects a 240 million bushel Kansas harvest. That is a 31% decline from the 2025 harvest. The U.S. wheat picture is even more striking when you look at acreage. American farmers planted 43.8 million acres of wheat for the 2026 season. That is down 3% from 2025, and the lowest U.S. wheat planting since the year 1919. American wheat production has been retreating from peak acreage for a generation, and the 2026 drought has accelerated the retreat. Now look at hurricanes. On April 9th of 2026, Colorado State University's Tropical Weather and Climate Research Group issued its seasonal Atlantic hurricane forecast for 2026. The forecast called for 13 named storms, 6 hurricanes, and 2 major hurricanes. The long-term averages are 14, 7, and 3. CSU is projecting below-average activity. The mechanism is the developing El Niño. As the Pacific warms, the tropical Atlantic experiences increased vertical wind shear, which suppresses tropical cyclone development. CSU pegged major hurricane U.S. landfall probability for the entire coastline at 32%, versus the climatological 43%. For a drought-stricken southeast, this is exactly the wrong outcome. Hurricanes, and the weaker tropical systems that often follow them, historically deliver substantial summer and fall precipitation to the southeast. A below-average hurricane season removes one of the few mechanisms that could naturally end the drought before late fall, so the same El Niño that may eventually deliver relief to the U.S. Southwest is, at the same time, suppressing the Atlantic systems that could deliver relief to the southeast. And then there is Lake Powell. As I mentioned earlier, Lake Powell sits at 23% full and is on a trajectory that could approach the 3,490-foot minimum power pool threshold by late 2026 or early 2027. If that happens, Glen Canyon Dam stops generating power. That is a hydroelectric facility that supplies power to about 5.5 million customers across the western grid. Every one of these consequences traces back to the same drought record, and every one of them is set to get worse before any relief arrives. This is the part of the story that has not landed in the broader news cycle. The Super El Niño that most forecasters expected to drive the worst climate impacts of 2026 and 2027 has not even arrived yet. NOAA's Climate Prediction Center issued its May 2026 ENSO diagnostic discussion last week. The discussion places the El Niño Southern Oscillation currently in neutral conditions. The Pacific has been transitioning out of weak La Niña and is now sitting at near zero anomalies. El Niño is favored to emerge during the May, June, July window, 61% probability, and to persist through the end of 2026. And the discussion places a 1 in 4 chance that the Niño 3.4 anomaly reaches or exceeds plus 2 degrees Celsius later this year. That is Super El Niño territory. The European Center for Medium Range Weather Forecast's CS5 model plume from May 1st. Of 2026 projects, essentially 100% probability of strong to Super El Niño by November. Some individual ensemble members in that plume exceed plus 3 degrees Celsius. The International Research Institute for Climate and Society's April 2026 Quick Look forecast places El Niño persistence at 88 to 94% through the rest of the forecast period. So here is the temporal anomaly that nobody has been able to fully sit with. The United States just broke a 131-year drought record by 3 separate metrics before the trigger fired. The Super El Niño that historically drives the largest disruptions has not even arrived. The drought has set its historic mark during the pre-trigger window. When El Niño finally develops, its precipitation effects in the U.S. Southwest historically arrive in late fall and winter. That means 6 or more months of continued drought intensification through the peak summer fire season before any potential rainfall relief reaches the Southwest. During that window, the cattle herd will keep contracting, the wheat harvest will come in below trend, the reservoirs will keep dropping, and the fire season will run hot. And there is one more piece to this. El Niño does not relieve drought everywhere. The teleconnection pattern that El Niño produces, the way it shifts atmospheric circulation across the entire tropics, relieves drought in some regions and creates drought in others. Where El Niño typically brings drought: India, Indonesia, northeast Brazil, southern Africa, eastern Australia. These are the regions that experienced the worst impacts during prior Super El Niños, most notably the 1877 to 1878 event, which produced what historian Mike Davis documented in his 2001 book, Late Victorian Holocausts, as a global famine that killed between 30 and 60 million people. India, northern China, and northeast Brazil bore the worst of it. The current developing El Niño has model ensembles projecting peak Niño 3.4 anomalies in the same range as the 1877 event. The disruption mechanism, collapsed monsoons, failed rains across Indonesia and northeast Brazil, drought in southern Africa and Australia, operates on the same teleconnection pathways. The same event that may eventually relieve the United States is the event that historically does the most damage everywhere else. There is a claim circulating online that the current drought is the result of weather modification, specifically that HAARP, or government cloud seeding operations, are responsible for the pattern lock that is locking the Bermuda High over the southeast. Here is what the physics says. HAARP is the High Frequency Active Auroral Research Program facility in Gakona, Alaska. Its peak transmitted power is 3.6 megawatts. The energy budget required to influence a single mesoscale weather event, which is to say, a single thunderstorm complex, not a continental drought, is on the order of 10 to the 25th joules. That is several orders of magnitude more than the entire installed power generation capacity of human civilization could deliver in a year. A 2024 study by Yuan and colleagues in atmospheric chemistry and physics, and a 2016 study by Shearer and colleagues in reviews of geophysics, both rule out ionospheric coupling to tropospheric weather as a mechanism for the kind of pattern lock the country is experiencing. Cloud seeding is real, and it does work, but it produces measured precipitation enhancement of 5 to 15% under already favorable cloud conditions. It cannot create a continental-scale drought, and it cannot suppress one either. The driver of the current pattern is documented atmospheric circulation, the Bermuda High position, the slow-phase speed Rossby Ridge. Both of these are observable in real-time satellite imagery and reanalysis data. The data is not hidden. It is, if anything, drowning the public in detail. The more defensible skepticism is the opposite of the conspiracy framing. The data has been showing this for years. The reason no one is talking about it as a single continental event is that coverage has been fragmented into regional stories: Florida fires, California snowpack, plains wheat, Colorado River reservoirs, each one covered in isolation. Nobody has named the continental scale superlative until now. The United States is not in drought alone. India's meteorological department issued its 2026 long-range monsoon forecast on April 13th. The forecast calls for 92% of long-period average rainfall during the June through September southwest monsoon. That is the first below-normal monsoon forecast India has issued in 3 years. Pre-monsoon heatwave conditions across central India are already producing temperatures of 43 to 45 degrees Celsius. Indonesia's BMKG, the country's national climate agency, has forecast that the 2026 dry season will start earlier than normal, peak in August, and run longer than usual. As of early May, the agency had detected 23,546 peatland hotspots since January. Indonesia's 1997 peat fires during the previous Super El Niño released between 0.81 and 2.57 gigatons of carbon, equivalent to between 13 and 40% of global fossil fuel emissions for that year. Australia's Bureau of Meteorology issued its long-range outlook on May 7th. The outlook projects below-average rainfall for much of eastern Australia and southwest Western Australia through the June through August period. The Horn of Africa is already in crisis. 6.5 million people are facing high hunger entering 2026, including 2.5 million children. The Famine Early Warning Systems Network, FuseNet, issued an alert in December of 2025 stating that 20 to 25 million people across Somalia, Ethiopia, and Kenya need humanitarian food assistance. Southern Africa is worse. 5 countries, Lesotho, Malawi, Namibia, Zambia, and Zimbabwe, have declared national drought disasters. United Nations agencies estimate that 26 to 30 million people across southern Africa need urgent humanitarian assistance. Every one of these regions is in the projected El Niño impact zone, and the trigger has not fired. Here is what we are tracking from here. Over the next 30 to 90 days, watch the United States Drought Monitor weekly releases. The question is whether the recent slight improvement in Florida continues, or whether the southeast pattern lock reasserts itself and pushes coverage back toward the April peak. Watch the western snowpack melt. The runoff over the next 6 to 8 weeks determines whether Lake Mead and Lake Powell hit power pool threatening elevations later this year, or whether they get a temporary reprieve. Watch the fire season. The National Interagency Fire Center's outlooks for June, July, and August will be critical. Above normal potential is already on the map for the southeast Atlantic coast, the southwest, far west Texas, and the East Bay region of California. If the operational fire calendar continues running weeks ahead of schedule, by midsummer we'll be looking at numbers that exceed anything the country has seen in the last decade. Watch the wheat harvest. Kansas State University's economist model projects a 31% decline in Kansas production. Final harvest data through July will quantify the operational impact on grain markets and on the price floor for downstream products, bread, flour, and cattle feed. Watch the cattle herd. USDA's mid-2026 inventory reports will show whether the 74-year low is stabilizing or whether the contraction is deepening. With 60% of cattle in drought counties expect deepening. Watch the El Niño development, NOAA Climate Prediction Center. Monthly, ENSO diagnostic discussions through the summer will track whether the projected Super El Niño materializes. The key thresholds are the Niño 3.4 anomaly crossing, plus 0.5 degrees Celsius, the El Niño threshold, and plus 2 degrees Celsius, which is the Super El Niño line. Watch the hurricane season. Colorado State University's June and August updates to the 13.62 forecast will refine the Atlantic suppression projection. And watch the Bermuda high position. Its westward extension is the same pattern driving the southeast drought. And watch the global signals. India's monsoon onset in late May and early June. Indonesia's fire hotspot evolution through the dry season. The Horn of Africa rainy season. The headline today is a 131-year drought record. But that record was set before the trigger arrived. What it tells us is not what the climate is going to do. It tells us what the climate has already done. The question is how much further it goes before relief arrives, and whether that relief brings its own consequences when it lands somewhere else on the planet. The Space Desk will be tracking this as it develops.